Hi guys, welcome to another episode of the Iraqi Nutrition Podcast. I'm your host, Juma Iraqi, and joining me today is Professor Darryn Willoughby from Baylor University. Darryn, how are you doing today?
I'm doing very well. How are you?
I'm doing great. Thank you so much for agreeing to do this podcast. So, topic for the day is fasted cardio, and you just recently had a study published on this topic, so it will be really interesting to talk about what the results and your findings were. But before we get into the questions, for people that haven't watched our previous podcast that we did on creatine last year, could you give us an introduction about yourself?
Sure, and also thank you for having me on again. It's quite an honor, and I really enjoyed the last time that we had a chance to talk and visit, so it was very insightful. So,
thank you so much. I appreciate that.
So, you bet. Thank you. I'm a professor here at Baylor University in the Department of Health, Human Performance, and Recreation. I'm also the director of the Exercise and Biochemical Nutrition Lab, which is a lab that I started when I came to Baylor about 13 years ago. I also have secondary appointments here at Baylor in the Department of Biology and also the Department of Biomedical Science. And my PhD is in exercise physiology, and it's from Texas A&M University. But I specialized in muscle physiology and biochemistry, and then I subspecialized, or I guess minored, if you will, in nutritional biochemistry and molecular biology. So my overall research interests involve the role of resistance exercise and the impact it has in skeletal muscle on hypertrophy-related processes, both at the biochemical and the molecular level. So we're interested in looking at how various types of genes and proteins behave in response to resistance exercise, and also in some cases nutritional intervention. That might be in response to some type of a supplement, if you will, whether it's protein, carbohydrate, branched chain amino acids, leucine, whatever the case may be. And then I'm also interested in looking at the effects of muscle damage or inactivity and the role that it plays in regulating muscle atrophy. So, we're interested in a number of different genes, if you will, that are upregulated, that are proteolytic related genes that are upregulated in muscle that play a role in degrading muscle and such. And to go along with that, I'm interested in the role of cortisol and in response to stress and that whole role that it plays in upregulating skeletal muscle proteolysis as well. So,
wow, interesting. And you're also a bodybuilder yourself, right?
Yeah, I am. Yeah, I am. I still compete in bodybuilding. So about a year and a half ago, I've got my professional status in a newer organization called the Global Bodybuilding Organization. It's certainly not the IFBB, and it doesn't try to be the IFBB, but it's still nice for somebody that's been lifting as long as I have, over 30 years or so, and still competing every now and then, and I enjoy it. I love it, but competing is kind of more of a hobby than anything else. I mean, I'll always train, but it's not something, obviously, I know that I'm going to be making a living at. It's just one of those things that competing gives me extra motivation on a daily basis to go to the gym and grind away. So, but it is something that in college, and I played football, and after college I played semi-pro football for a number of years, and so in addition to continuing to lift and bodybuild, and it's kind of always been somewhat of an athlete and highly involved in exercise and training, and I always will be. So, the nice thing is it gives me a chance to kind of practice what I preach. So, not only do I do what I do to make a living, I also do the exact same thing in my personal life as well. So, so it makes it kind of nice.
Yeah. And I think it's really interesting to mention that, because a lot of people have this impression that researchers and scientists they don't even lift, they don't get
Right.
involved in physical activity and stuff. But
Right.
like I often struggle to actually find like researchers in exercise and nutrition that aren't athletes or were previous athletes. I can't really think of anyone that hasn't been involved in some way in some type of sport.
Right.
So, and I remember when I met Dr. Jose Antonio in London last year at the ISSN conference, and he told me, Juma, you should do a podcast with Professor Darryn Willoughby, but I should warn you in advance. He's probably the biggest and most muscular professor you'll ever have on your show.
Yeah, maybe so.
Yeah. All right. So let's start with the question, because like fasted cardio has been around for ages in the bodybuilding and fitness industry. So let's first start to talk about what the proposed benefits to doing fasted cardio are.
Well, the proposed benefits are that, if you if you embark on a cardiovascular exercise or aerobic exercise session under a fasted condition, then the theoretical construct for that is that substrate utilization is going to be more preferentially directed towards fat oxidation, because based on the fast, and the fast is going to depend on how long, if you will, and the reason I say that is because the longer someone's fasted, the more catabolic they're going to be. But anyway, it deals on the aspect of the fast itself. And so that being said, during the fast, the body will rely, or at least early in, the body will rely a good amount on carbohydrate and glycogen as a fuel source, that is a substrate for energy production. And so then at some point in the fast, later on in the fast, then up to the point in which somebody begins to exercise, and theoretically, then the body will preferentially begin to utilize and rely more on fat because of the relative unavailability of glucose. And so that being said, as he said, is that the proposed benefit of that is that now, while we exercise, and obviously as we exercise, we're increasing energy expenditure. So as we begin to exercise, and the body is going to have to rely primarily on fat to be able to use that as the substrate for energy that's created during exercise. So bottom line is that because the body is going to, or theoretically is going to rely more on fat as a fuel source, then a person's going to be able to burn more fat, and obviously over the course of time, then lose more body fat as a result of this type of training.
Okay, I'll get to a follow-up question on substrate utilization later on, but before we get to that, like I said, this strategy has been popular for several years. Why do you think bodybuilders in particular opt to do fasted, low intensity, steady state cardio compared to high intensity? Do you think it's because of the fat burning zone, that like when intensity is lower you use more fats as a substrate, or do you think that it might have something to do with low intensity cardio is not really something you need to recover from, but if you do a lot of high intensity, it might have an effect on your total recovery ability if you're also doing a lot of resistance training? So what do you think? Is it more on the recovery part, or do you think it's more on the being in the so-called fat burning zone?
Actually, it's probably a little bit to do with all of that, because relative to reliance on probably with more fat than carbohydrate. That's certainly an aspect of it. But you mentioned earlier about why bodybuilders, for instance, may rely more on the lower intensity steady state cardio than the higher intensity interval training. And so, I don't know. There could be several reasons for that. One might be, as you said, maybe it's just for a long period of time, that was the typical mode for doing cardio before. If you think about it relative to HIIT training is still relatively new if you think about it. So, but the mindset for cardio is probably still more so based on simply just lower intensity, working more in your so-called fat burning or your target heart rate zone, your so-called steady state. And so doing, that's supposed to be the most optimal point for utilizing fat.
Mm-hmm.
And so that could be it, just based on that's just kind of what's still somewhat popular and what people tend to categorize cardiovascular training to be. The other could be simply that maybe perhaps some people don't necessarily like doing HIIT training. I mean, because, even though you're not going to be typically doing it quite as long, I mean, it's higher intensity. There's, sprint work and things like that, such as involved, meaning compared to the lower intensity steady state cardio. So, it could be something that's people don't necessarily enjoy, if you will, the HIIT approach.
Mm-hmm.
So, the interesting thing here is, at least what we've seen, is that the difference seems to be relative to the amount of energy expenditure that's done or that occurs, is that with HIIT training, or at least with a single bout of HIIT training, HIIT exercise, is that most of that energy expenditure is going to occur after exercise, beyond the exercise bout itself. So in several hours after the exercise, opposed to actually during the exercise, if you will, with the lower intensity steady state cardio. So, for instance, you're not necessarily, or so the data seems to suggest, that you're going to burn as many calories during the exercise session while you're doing HIIT, but you end up burning more calories in the post-exercise period compared to the other training protocol. So, that could factor in as well. So, I'm not sure that there's actually at least in my mind, I'm not sure that there's actually one specific direct answer to that. It's probably a lot of things. Personal preference probably being one of them. So.
Yeah.
And maybe the other thing, just based on some of the bro science that's picked up on social media or wherever it might be. So I don't know. It's kind of hard to say.
Yeah. No. I think like you said, it's probably going to be several components that make people choose low intensity compared to a high intensity. But you mentioned something about when you do low intensity, you basically look at the calories you burn during the exercise, but when you're doing HIIT, most of the effect you're going to get is after the exercise. So that brings me to my next question, and that is, do substrate utilization have an effect on body composition in the long life? For example, people often do low intensity cardio training to burn more fat, and the lower the intensity, the more fat is going to be oxidized during the session. But if you're still consuming an excess amount of calories, it doesn't seem to really matter. Could you please just touch upon that? Because I think that's an area where people get really confused, that they immediately think that increased fat oxidation means you're going to get leaner.
Right. Mm-hmm. No, actually, I think that's a very, very good point. And I think people need to understand that some of the the aspects that regulate substrate utilization. There are a number of them, but some of the more primary aspects are simply just based on the role that various hormones play. And we know, for instance, insulin will inhibit fat oxidation. And we know a lack of insulin, if you will play a role on helping to upregulate fat oxidation. And so that being said, is that if somebody eats a meal that contains carbohydrate, and then shortly thereafter, then they go and they jump on the treadmill or the bike, or they run out, they're running outside, whatever they're doing, but then they're doing cardio, let's say, lower intensity, steady state cardio, and they're doing it thinking that they're going to be, inducing a preferential fat burning effect. That's likely not going to be the case, because at least in the early to middle stages of the exercise, depending on the duration of the exercise, the body is going to be relying on those carbohydrates that they just ate in that meal to fuel that exercise. Even if it's a lower intensity, it's immediately available there. And so sometimes people think that, well, if I exercise low intensity enough and long enough, irregardless of the fact that I have carbohydrate available, and/or I have an appreciable glycemic response in my blood, then I'm still going to be significantly upregulating fat oxidation or relying on fat as a fuel source, and that's not necessarily the case. And that's kind of back to your earlier question about this issue of fasted cardio. You come into cardio fasted, so your insulin level, your blood glucose level is going to be low, therefore your insulin levels are going to be low. So that can play a role in upregulating fat metabolism, fat oxidation, because that's going to preferentially be the fuel source that's going to be utilized during exercise. So the other part of your question comes in, well, what about exercising? So, talking about exercising either fasted or, eating, for instance, right before, particularly carbohydrate, right before exercise, or perhaps instead eating in what we call in the post-absorptive state, where it might be, a couple of hours or so after a meal. By that time, your nutrients relative to digestion and clearance have been able to kind of run their course. So, at that point in time, you're not going to have, or at least you shouldn't have, elevated insulin levels in the blood, at least not significantly. And so in that point, and in that case, you do have glucose available relative to glycogen in muscle and perhaps in liver as well. So you can then perhaps play a role there of maybe also relying on fat metabolism in that particular case to some extent. But compared to, say, in a fasted cardio state, you've also got carbohydrate there to also help support muscle protein synthesis as well, so that you're not upregulating fat metabolism all the while. Protein metabolism. Which this could be the issue with fasted cardio, because in a lot of cases, people show up to do exercise in a fasted state. They're catabolic. Yes, their body will be relying on fat as a fuel source, but it will also be relying to some extent on protein. Because of the catabolic state, cortisol levels are going to be elevated. We know that cortisol will induce muscle protein degradation. And the role of that protein degradation is so that the body can also use protein as a fuel source as well. So, for bodybuilders, for instance, fasted cardio may not necessarily be a good thing for them to do, because they're wanting to try to hang on to their muscle mass as much as they can. So in a prep period, you don't necessarily want to be not only dieting, but you don't want to be exercising based on your cardio off some of the muscle mass that you work so hard to put on during the off season. So in that particular case, it might be more beneficial for them to do their cardio more in a post-absorptive state, or perhaps it's, if they're gonna come at their exercise in a fasted state, then they may want to at least try to take in some protein, for instance, whey protein, or a very rapid absorbing protein prior to the exercise itself.
Mm-hmm.
Even though that will generate an insulin response, it's not going to generate the same type of insulin response as if they were to eat carbohydrate. So,
yeah, that's excellent explanation. And it's a bit ironic that people are so obsessed with getting in nutrients right after resistance training session to get out of the catabolic state, but they will do fasted cardio in the morning after several hours without eating.
Exactly. Yeah, for sure.
Yeah.
I mean, in some cases, if their last meal was, like, say, non-military time, let's say 7:30, 8 p.m. the night before, and then they get up the next morning, say at, I don't know, 6 or 7 a.m., and then they start doing cardio. I mean, that's been, about 12 hours. Of course, their metabolic rate begins to drop at night while they're sleeping, but nevertheless, mm-hmm. that's a fairly long period of time that they've gone without eating, and so the extent of catabolism can be quite dramatic. Mm-hmm. And so over the long haul, day in and day out, if you will, of doing fasted cardio, particularly say in a bodybuilder or physique competitor. They likely will be being able to drop some fat mass off of their physique, but at the same time, they're most likely going to be dropping off muscle mass as well. Mm-hmm. So, you have kind of a unique scenario here as to, how can I decrease fat mass while hanging on to as much of my muscle mass as possible? And so, it ends up, at least in my opinion, it ends up being totally based on nutrition. Mm-hmm. How are you going to use nutrition to be able to offset that? Well, one would be able to, as I said, perhaps take in protein right before cardio. Mm-hmm. So, you're not actually doing a true fasted cardio, but at least you do have some type of nutrient on board that can help buffer mm-hmm. and help support muscle protein breakdown. Or perhaps instead do the cardio in the post-absorptive state as well. Mm-hmm. So the data that's available as you know is kind of mixed. But some of the studies, and they're talking about in subjects who are not necessarily bodybuilders, for instance. But there's some data that positively reflects on fasted cardio for fat loss and increasing fat oxidation. But those studies don't necessarily actually look at the impacts that it has on protein degradation as well. Mm-hmm. So some people just say, oh my goodness, fasted cardio will help me lose fat. Mm-hmm. Okay, well, yeah, it can, but at what expense on your muscle mass? Yeah. So some people may not care about their muscle mass. I just want to lose fat. Mm-hmm. Okay, well, then in that case, you might be able to benefit from fasted cardio. But in the case of somebody who's really concerned also with maintaining their muscle mass as well, it's probably something they should try to avoid if they can.
Yeah. So let's get into the study that was recently published. Can you tell us more about who were the participants in the study? What were you actually looking at? What methods you used and the results that you got from the study?
Sure. We actually didn't necessarily do this study because we were specifically interested in looking at fasted cardio versus non-fasted cardio. Mm-hmm. We did this study, and this study was done by at the time, she was one of my master's students, Elisa Morales, and now she's stayed on. She's here. She's one of my PhD students. But and so she proposed wanting to do this study, and so and of course we did. But we came at it with the approach of looking at the role that exercising without in a fasted versus a non-fasted state, exercising in that scenario and looking at the effects that it had more biochemically and molecularly. We were wanting to see what effect that it might have on uncoupling protein 3 and skeletal muscle, and we were also interested to see if a beta aminobutyric acid, or what we call BABA, which is a myokine, if that perhaps had an upregulating role on uncoupling protein 3. Uncoupling protein 3 very quickly is just the proteins in the mitochondria that are involved in dissipating heat via the electrochemical gradient and playing a role in helping to chaperone protons back into the mitochondria, which are then used to make ATP in the mitochondria. So, studies have shown that, if you can increase the expression of UCP3, then you can actually increase energy expenditure in skeletal muscle. So we're wanting to see the effects, for instance, that exercise had on UCP3 expression, and we looked at it both at the gene level and the protein level, and then we are also interested to see if BABA had any type of impact on that as well. And so we took males who were not trained. They weren't endurance trained. They weren't resistance trained. We had them do 30 minutes of cycle exercise. We standardized the exercise so that they exercised to the point at which they expended 350 kilocalories. So we didn't set it up based on that they exercised for 30 minutes, for instance. We set it up so that they exercised in duration until the point in which they expended 350 calories. And it ranged the duration, and we kept the all the parameters on the bicycle the same in terms of load on the flywheel and all that. So in that particular case, all the times for all the subjects ended up being roughly the same, and it was like on the mean was about averages about 26 minutes that it took them to expend 350 calories. So anyway, and then from our blood draws, we looked at glucose, we looked at free fatty acid levels in the blood, and what we saw is that we didn't see really any impact on BABA. However, a limitation of the study is that we only looked at BABA in the blood. We really should have looked at and needed to look at it in muscle, and one of the reasons we didn't do that is that it's very, very difficult, and at least in our case with our mass spectrometer, is that, which is how we used it to measure BABA in blood. But for instance, tissue homogenous like muscle or other tissue homogenous, sometimes you can't get it homogenized fine enough to inject it into the ejection port of the mass spec without clogging up the mass spec. And so it was something that we were having trouble with. So at least for this study, we just we didn't do it in muscle. So if I would say that to really know for sure the impact that BABA may have on UCP3 is that we really would have needed to run BABA in muscle. But anyway, but what we saw is that we saw increases in UCP3 gene and protein expression that were greater than that were greater in the fed condition than in the fasting condition. And then when we looked at free fatty acid levels in the blood, we saw increases for both of those within each condition, but they weren't any different from one or the other. So if you use changes in free fatty acid levels in the blood as a marker or an index of fat oxidation, fat metabolism, lipolysis, triglyceride breakdown, for subsequent use for fuel source and all that, however you want to refer to it, is that we saw obviously exercise increase that, but we didn't see any difference between the two, whether it was in the fed condition or in the fasted condition. So we saw some differences for UCP3. meaning that exercise definitely increased in both conditions. Both increased it. We saw slightly greater increases in the fed condition over the fasted condition. Mm-hmm. So really, what the take-home message from the study is that we really didn't see anything between the two types of conditions, meaning in the fasted condition or the fed condition, that would, at least in this study, bearing the limitations that it has, and all studies have limitations, we didn't see anything in there that would suggest that exercising in a fasted state is more beneficial than exercising in a non-fasted state. So,
excellent. Now, I've read the paper, but for people that haven't read it, could you also mention what like in the fed group, what did they actually consume before the cardio?
What was the meal? Yeah. So we had them. They all ingested the exact same thing, and we had them have a meal replacement shake, Ensure. Mm-hmm. So that was the drink. That was the drink that they ingested. So I think it ends up being. I think it's like 280, right around 300 calories, something like that. Mm-hmm. No, actually, I take that back. It's about 350 calories. So that's why we set the exercise session up to expend 350 calories, so that it was basically the same as what they were taking in relative to the meal. So, okay. Yeah. So it's just it's just a standardized drink. We did that rather than we didn't want them to eat on their own. We wanted to. So when they came to the lab, we gave them the shake. We watched them drink it, so we knew that they were actually taking it in, mm-hmm. relative to relying on them doing it on their own, and instead of saying, okay, eat eggs and bacon or toast or whatever. That way we would know, because we could keep things standardized across the board.
Yeah, excellent. And you just have to trust that they didn't eat before they came.
Yeah, exactly. Well, yeah,
in the fasted group.
That's one of the issues, or a number of the issues that go with using humans in research. And in my lab, we don't do animal work. It's only human work, and you deal with those limitations, and you hope and you trust that your participants will comply, and mm-hmm. in this case that they didn't eat coming in, and actually I think that might be, I can't remember, a limitation in the study, and that was pointed out, and whether it's that or sometimes when we do supplementation studies, we're hoping that the subjects are taking their supplements like they're supposed to, and all that stuff. So mm-hmm. And when we have them do dietary recalls like they had in this study as well, we're hoping that they're being truthful with the dietary recalls and telling us everything that they did eat and the amounts are correct. And so that's why, not just with my studies, but that's why with so many of these studies, particularly with humans, mm-hmm. they all have to be interpreted with caution, because human behavior is just something that no one has any control over. At least with rodents, for instance, you can control pretty much everything: how much light they get, how much dark they get, how much water they get, how much food they get, how much activity they get. Well, obviously we can't do that in humans, most of the time. So mm-hmm. it makes it a bit difficult many times, and you just have to try to allow for those limitations and try to design your experiment accordingly around those limitations, and just try to envelop them as best you can. So
yeah, I think people should be involved in a research project at least once, just to see how much work actually goes into, because it's really easy to see it on social media and criticize, why didn't you do this and why didn't you do that, and people don't necessarily realize that money might be, like funding might be an issue, yeah. Availability of equipment, participants, like there's a lot that you have to consider but it's really easy to say, why didn't you do this, and this, and why did you do this instead?
Well, you know what? I'm glad you mentioned that, because that's an excellent point. Especially when you go on social media and, in response to studies people will post on, you see all these people criticizing. One, they have absolutely no clue what research is all about. Number one, from the standpoint that, they've never done a research study. They have no idea what goes on to in a research study. They may have some knowledge about the construct behind the study, whether it's, protein metabolism, carb metabolism, whatever. But in terms of actually doing a study, and as you mentioned, everything that goes into a study at the design stage, and all the limitations that go involved in that. I mean, they just, so many people just have very little clue and very little insight into what goes in. I've been doing this for 25 years, designing and doing research studies, and there's no such thing as a perfect study. It just does not exist. Mm-hmm. There are too many things to consider there, particularly when you work with humans. And so it's always easy to criticize from the cheap seats. Mm-hmm.
Yeah.
You're not involved. You sit back there, and you have. I mean, it's always easy to throw rocks when you don't have a dog in the fight, if you will. And so it's, I have a lot of colleagues that, they really get kind of angered by it all, but I just, I don't. I'm just, it is what it is. It does not impact on what I do. I mean, my work is good. My work is solid, and with integrity, and it's just. But the thing is I mean, the results, they are what they are. People can interpret results for a study in any study any way they want. And matter of fact, I was just a couple of days ago. I was kind of going through some of the just to see if anything new had come up recently on the fasted cardio stuff, and I found something online about websites somebody had, and they were talking about fasted cardio, and they were making this point about it, and they referred to this one study, and they had the link to it. So I clicked on the study, and I went and started looking at the study, and I realized that the point that they were making, and they were justifying fasted cardio, the point that they were making had nothing to do with the study. They had completely misinterpreted the study, mm-hmm. and were completely misconstruing the results to support their bias. And I just kind of shook my head, and I'm like, okay, it's just, and I get it. Sometimes some of these studies are not easy to interpret. Some of the studies are pretty involved, and some of the science is very, very, very involved, and again, sometimes it's a bit difficult, but nevertheless, again, the results of a study are, need to be perceived for what they are. It's just one study, and the other thing is that, and you alluded to this earlier in our talk, and I think it was a very good point that you made. Mm-hmm. When you talked about some of the studies where like in our case, the study that we did, I mean, you're talking about having these people come in one time. It was a crossover study. They came in and exercised one time. Well, if we brought them back in for another exercise session or a third exercise session, would we see the same thing? Mm-hmm. Maybe not.
Yeah.
So that's a limitation relative to taking our data. And I'm the first person that will throw rocks at my own research. Believe me. Mm-hmm. I'll read it after the fact. I'm like, why did we do that? I'll read my studies from like 5 years ago, and I'm like, why did I do that? I should have did it this way. So I'm humble enough and modest enough, and that I'm the first person that will criticize my work if need be. But you made mention of some of these studies that relative to fasted cardio and such, and a number of other topics as well, where they just use one bout of exercise or one bout of nutritional intervention or whatever the case may be. And like with studies where they've done protein metabolism, one bout of resistance exercise, and they gave whey protein after exercise, and they had some really cool data. Mm-hmm. and you're showing, increases in muscle protein synthesis and so on and so forth, but that's just for that one resistance exercise session. Does that mean that it's going to translate into muscle hypertrophy after 12 weeks of training?
Yeah.
We don't know.
Mm-hmm.
The data implies it, but we can't know for sure. Just like with our study, it doesn't mean that if these guys came in and were doing this for, a month, that we might end up seeing something completely different. Yeah. Maybe not, but so.
Are you considering doing a follow-up study to look at other things regarding fasted cardio?
I'm not sure. It's possible. Mm-hmm. I'm thinking now about trying to maybe instead do doing something, looking at hypocalorism, where we can attempt to control as best we can in humans, but where we can look at do some for about maybe a month or so, where we can do some hypocaloric approaches, because one of my big interests now, particularly relative to being in bodybuilding and such, is muscle hypertrophy, is the role that hypocaloric diets play on inducing muscle protein degradation. Mm-hmm. And so, so many people many times will, and even bodybuilders will do this in some cases, or physique competitors will undereat, but they will try to eat higher protein intakes. But the fact that they're eating higher protein doesn't necessarily mean that it's going to rescue muscle protein degradation if they're not eating enough calories throughout the course of the day. Mm-hmm. And there's a really cool study that was published in 2016. They used rodents where they did something like this, where they had them for a month. They had the two groups that ate ad libitum, and then they had one of those groups they adjusted where it had 10% protein, and the other ad libitum group had 32% protein. And then they had two groups that were based off eating 40% of the two ad libitum groups. One of the groups had 10% and the other group had 32%. So the other two groups were eating 40% less calories than the other two groups. One of them had higher protein content in their diet, though. But they still showed that these two groups that were under eating, hypocaloric, if you will, regardless of the protein content, it had no impact on the fact that those groups of rodents lost significant amounts of muscle mass, muscle protein degradation, and they were, muscle protein content, for instance, in the gastrocnemius was significantly less. So, even though the groups that were eating pretty much all they wanted, they increased fat mass. Well, of course, the under eating groups really had no impact on their fat mass per se, but their muscle protein content was drastically reduced. So, I'd like to try to do something like that in humans if I could, where because that concept, kind of like fasted cardio, mm-hmm. is quite prevalent in physique competition. Under eating, but trying to rescue muscle protein. Muscle mass by eating higher protein intakes, even though you're under eating. Mm-hmm. And so I suspect that that's not going to help much. So yeah. It's more about trying to hit your numbers relative to total calories at the end of the day, irrespective of just eating higher amounts of protein, even though you're under eating overall. So
yeah, that would be interesting to have a study like that, because like you said, it's very typical in the bodybuilding community or the physique world that people undereat and try to compensate by eating higher amounts of protein. So regarding fasted cardio, what would, like, if you were to sum it up, what would be your take-home message on this topic?
My take-home message would be somewhat the same as I mentioned earlier in our talk. Mm-hmm. Is that when somebody asks me is fasted cardio a good thing? Well, sometimes my answer will be yes, and no.
Mm-hmm.
It depends on what the person's goal is overall.
Mm-hmm.
I mean, if you're talking about somebody who is who has a relatively high body fat level, the issue in here comes in the fact that obviously things need to be done to the diet and just exercise in general.
Mm-hmm.
If somebody has a relatively low body fat percentage, for instance, then they might see a more noticeable impact with doing fasted cardio. But like I said, back to what I was saying, is that if somebody is not concerned about their muscle mass at all and maintaining muscle mass, and for them it's just all about just losing fat mass, then then they may be able to get a beneficial effect from doing fasted cardio. If you're talking about somebody who is interested in decreasing fat mass, but also trying to maintain their muscle mass, or put it on, because if you're talking about maybe a bodybuilder who's still in the gym grinding away, and they're still trying to put on muscle mass, if you will, with their training,
mm-hmm.
then in that case, fasted cardio is probably not the best approach for them based on that scenario. So, that being said, I would say if in that scenario, then the take-home message would be if they insist on doing cardio in a fasted state, or at that point in the day, for instance, and it just corresponds to them getting up and doing it early in the morning, then they probably should put some protein on board. So take in maybe a whey protein shake or something where they can get some rapidly delivered protein in that's not going to dramatically affect their insulin level, but at least it could play a role in helping to protect against some amount of muscle protein breakdown. And if that's not the case, then maybe perhaps either later in the day or at some point in the day, but in a post-absorptive state, after they've eaten, but digestion has been able to occur, and so they don't have high levels of insulin, but yet they have carbohydrate available to be able to help support muscle protein synthesis. But they also are able to rely to some extent on fat as a fuel source as well. So they would kind of have a mixed substrate oxidation component in that regard. So, and studies have shown that type of approach, you still get an appreciable effect on fat oxidation, mm-hmm. in that it's not blunted from having carbohydrate available in a post-absorptive scenario. So, and then from the standpoint of somebody's going to come in and day out over however long period of time, then that's the main impact here, is that what type of consequences is going to have after 8, 10, 12 weeks or whatever the case may be, mm-hmm. on not only your fat mass but also your fat-free mass as well. So, because most of us, even though we want to whittle away at our fat mass, we don't want to do the same thing to our muscle mass. We'd at least like to maintain it. So, I know I'm that way. I know you're that way, and I know most all physique competitors are that way. So, being able to try to rescue that as much as possible, I think definitely is something that should be a take-home message here. So, and in that case, it would be probably try to avoid fasted cardio as best you can.
Excellent. I think that was a great summary of what we talked about, and also a great take-home message. So thank you so much for taking the time to do this podcast. It was a real pleasure as always. Is there anywhere where people can find more information about you? Are you active on social media, for example?
Yeah, I am. I'm on Facebook. It's just you can search for me just under my name, just Darryn, Darryn, and Willoughby, Willoughby. My wife and I have a joint account, which is kind of more a personal account, and then my other one that's just Darryn Willoughby. that's more of my professional account. So that's where I'll post stuff about research that we're doing and studies that we have published, and things along that line. I don't really do any personal stuff on there. That's what my other one's for. So so there, and then if they want to check in and about any of the research that we're doing, then you can just type in my last name and my first initial D, and then in say like PubMed, Medline, and all of our studies will come up. Our PubMed index studies will come up, and there's a whole list of them in there that go. And then most of them all involve resistance exercise and/or nutritional intervention in some way or another. So, yeah, that would be the best way.
Yeah, excellent, Darryn. Once again, thank you so much for taking the time, and hopefully we can do another podcast on another topic very soon.
I look forward to it as always. So it's been a pleasure, and it's been a pleasure visiting with you, and I look forward to it.
Thank you so much, Darryn, and have a nice day. It's still what's the time now in the States? Like 1 o'clock approximately.
1:15.
1:15, yeah.
Yep.
So I'm on the other side of the world, so I'm gonna hit the sack soon and get some quality sleep for those gains.
Well, hey, it's all about recovery, right?
Yeah, exactly.
Yeah.
All right.
It's not necessarily how hard we train, but it's how hard we recover, how effectively we recover.
Yeah, it's a highly overlooked. It's a highly overlooked what people do when it comes to recovery. Like they'll focus on the training and maybe on the nutrition, but sleep is not.
Actually, hey, maybe that could be a cool future podcast.
Yeah, absolutely. We can talk about strategies regarding recovery.
Oh,
that would be great.
Absolutely.
Yeah. All right,
Sure.
Darryn. Thank you so much, and wishing you a pleasant weekend. And also, it's Easter next week, so happy Easter as well.
Thank you, and you take care of yourself as well.
Thank you so much. All right, Darryn. Have a nice day.
All right, you too.
Thank you. Bye-bye.